So why is the speed of light such a brutal, unbreakable limit? Let's investigate why this isn't just a technical hiccup, but a fundamental boundary that shapes our place in the universe. To truly grasp this cosmic speed limit, we need to look beyond science fiction and see what the laws of physics actually demand. So what makes the speed of light the ultimate wall for space travel? The consequences of misunderstanding this are massive. If we keep hoping that a miracle technology will appear, we risk chasing illusions, pouring time and dreams into goals that can never be reached. Worse, we might miss real opportunities, new worlds to explore, technologies to develop, and even economic power, right here in our own cosmic backyard. Are we forever stuck in our solar system, or is faster-than-light travel still possible? For generations, humanity has dreamed of traveling not just to nearby planets, but to distant stars and even faraway galaxies, just like in our favorite movies and novels. We picture heroic crews leaping across the cosmos at unbelievable speeds, turning the vastness of space into a playground limited only by our imagination. Why do we keep thinking we can break the speed of light? Blame science fiction. But what if this vision is more fantasy than future? What if, no matter how clever our engineers become, no spaceship will ever break free from the ultimate barrier set by the universe itself, the speed of light? Pop culture teases us with starships that zoom between worlds as easily as crossing a street. Science fiction suggests that with one groundbreaking discovery, we could make these impossible journeys real. Yet actual science tells a very different story, one with rules that cannot be bent. But here's the problem. Hollywood's convenient shortcuts ignore the stubborn facts of nature. The universe isn't written by screenwriters, and the rules aren't up for negotiation. From Star Wars' effortless hyperspace jumps, to Star Trek's warp drives, to wormholes in movies like Interstellar, pop culture has trained us to see interstellar travel as just another engineering puzzle waiting to be solved. Every blockbuster and best-selling novel makes it look easy. Press a button and you're in another galaxy by lunchtime. Physics is clear. Nothing with mass can reach the speed of light, let alone break it. This isn't an arbitrary hurdle. It's built into the very structure of everything. The closer anything gets to light speed, the harder it becomes to keep accelerating. In fact, you'd need infinite energy to even try. So what does the universe really say about why we can't go faster than light? To understand that, we need to look at what happens when you push a spaceship toward those ultimate limits. Yet the more we see these sci-fi solutions on screen, the easier it is to confuse fun storytelling with real science. We start to believe that with enough cleverness or the next big breakthrough, we'll just leap over the barrier. That's a dangerous illusion. If we underestimate the true challenges, we risk being blind to what's actually possible and to the thrilling frontiers that still lie open to us. Let's explore the real physics behind the cosmic speed limit and why it's impossible for anything with mass to ever reach, let alone surpass the speed of light. Let's put fantasy aside and face the cosmic facts. The universe is not waiting for us to invent an engine to leap across the stars. The laws of physics, not Hollywood, set the rules, and those rules come with hard limits that we cannot wish away. This leads to a cruel paradox. To go faster, you need more fuel, but more fuel makes your ship heavier. That heavier ship needs even more energy to keep accelerating. The cycle spirals out of control, demanding an endless supply of resources. It's a race you can never win, no matter how clever your engineering gets. As you accelerate toward the speed of light, every added burst of speed comes at a steeper price. Your mass increases, not just a little, but endlessly as you approach that ultimate speed limit. This means the energy needed also grows without bound. No matter how advanced our technology, pushing any material object to the speed of light would require infinite energy, more than exists in the entire universe. But let's pretend for a moment that you could somehow solve the energy problem. There's another danger lurking in the void. The universe is not empty. Even a single atom of hydrogen can be deadly at near light speeds. Tiny bits of interstellar dust become bullets, hitting with the force of nuclear explosions. Just a few grains could tear a ship apart or flood it with lethal radiation, turning your dream voyage into a cosmic disaster before you even reach the halfway point. Ignoring these cosmic realities means pouring hope, effort, and resources into dreams that physics simply will not let us achieve. Every year spent chasing fantasies is a year lost to real discoveries and advancements we could make closer to home. So with these hard limits in mind, why do ideas like wormholes and warp drives still spark our curiosity? Then there's time dilation, the weirdest twist of all. As you get closer to light speed, time slows down for you compared to everyone back home. If you set off on a journey to a nearby star at 95% of light speed, you might only age 3 years while those on Earth wait 10. If you went to another galaxy, you might experience mere thousands of years, but millions of years would pass on Earth. The world you left behind would be gone forever. Your crew would return to a planet they barely recognize, or maybe no one would be left at all. And the final blow, even if you could travel at light speed, space is so vast that it still takes huge swaths of time to get anywhere. The closest star system is over 4 light years away. The nearest galaxy, Andromeda, is 2.5 million light years distant. For all practical purposes, the universe is just too big for us to hop across, even at the fastest speed nature allows. If faster-than-light travel is off the table, what makes these speculative shortcuts so seductive? And do they have any scientific footing at all? Can exotic matter, alien shortcuts, or new physics save us from the cosmic speed limit? Let's dig into the most popular workarounds and their harsh realities. First, warp drives. According to science fiction, these let us bend space and zoom between stars in days. But actual physics tells a different story. Creating a real-life warp drive would demand huge amounts of exotic matter with negative energy, a substance that may not exist anywhere in the universe. Even the most optimistic theories admit, without this impossible ingredient, warp drives stay in the realm of fantasy. Some dreamers hope that advanced alien civilizations have already cracked the code, possessing technology far beyond our wildest dreams. But at this point, alien tech is pure speculation. There's no evidence any species has beaten the laws of physics to visit us or travel the stars at impossible speeds. Betting our future on this hope is like waiting for magic to solve our problems. What about wormholes? These are shortcuts through space-time, like tunnels connecting distant parts of the universe. On paper, they sound like the ultimate cheat code, but in practice, wormholes are unstable, prone to collapse, and would bombard travelers with lethal radiation. Instead of a safe passage, you'd be walking into a cosmic blender. No known method can stabilize a traversable wormhole or shield you from its deadly hazards. So instead of getting stuck in frustration, what can humanity actually achieve within the real laws of physics? So what does the realistic future of space travel actually look like? The real breakthroughs are likely to come from robotic probes, artificial intelligence, and maybe, in the far future, crewed missions that accept multi-century journeys at a significant fraction of light speed. With enough patience and innovation, we could send intelligent machines to other stars, unaffected by human lifespans or frailty. Slow, steady progress might not make for thrilling movies, but it's the path that truly builds our cosmic future. So, if the laws of physics define the playing field, how can we turn these limitations into new opportunities? And what should humanity aim for as our next great leap? The risk is clear. If we get lost chasing fantasy solutions, we divert precious effort from developing real, game-changing technologies. The universe will not hand us shortcuts, but it does reward persistence, creativity, and engineering in the face of hard limits. Every real breakthrough in space has come from collective brilliance and determination, not miracles. Each step, from the first rocket to robotic explorers on distant worlds, demanded years of effort, creative thinking, and collaboration across borders and generations. Science doesn't kill dreams. Instead, it helps us shape ambition into something powerful and lasting. By accepting the speed of light as a true limit, we free ourselves to focus on progress we can achieve in our lifetimes, and maybe build the foundation for generations that follow. The speed of light is not a dead end, but a signpost pointing us toward challenges we can genuinely face. Solar sails, ion propulsion, and advanced nuclear concepts. These are not science fiction. They are practical technologies that could open up our entire solar system. Imagine gliding to the outer planets with sunlight as your engine, or sending spacecraft across the asteroid belt using streams of electrically charged particles. With these advances, colonizing Mars is not just a dream, it's a project underway. The asteroid belt could become our mining outpost, fueling industry back on Earth or in orbit. Even the icy moons of Jupiter and Saturn, like Europa or Titan, move from fantasy to frontier. Each of these goals is difficult, yes, but actually within reach if we work together. The speed of light isn't a curse. It's a challenge that unites science and imagination. So, when we talk about cosmic limits, what really matters in the end? Let's look at how embracing them shapes the future of our journey among the stars. But if we ignore these limits, chasing impossible fantasies, we risk missing the real adventure, the exploration and transformation of our own solar backyard. We could lose the chance to lead, to discover, and to make the next leap as a species. It's easy to see this universal limit as nothing but an obstacle. For decades, science fiction has shown us shortcuts and magic-like technologies, tempting us to believe we're only one clever invention away from leaping to other stars. But the laws of physics aren't waiting to be outsmarted. They are the fabric of reality itself. If we treat the speed of light as just another problem to solve, we risk missing the bigger picture. This cosmic speed limit is not the universe holding us back. It's the universe inviting us to focus on the frontiers that are within reach. In the same way that climbing Everest pushed us to understand our own planet better, exploring our solar system can unlock discoveries that transform our lives. When we accept the boundaries set by nature, our ambitions become sharper and more powerful. We can pour our curiosity and resources into building orbital habitats, harnessing asteroid resources, and exploring the mysteries of our neighboring planets. These are not consolation prizes. They are real adventures that could redefine what it means to be human. Your future as a space pioneer doesn't depend on breaking the speed of light. It depends on where you invest your passion and curiosity, on choosing challenges that are both bold and possible. This is how progress happens, by taking on the universe as it truly is, not as we wish it to be. So instead of mourning the limits, let's reframe them as the starting line for the next era of discovery. Every new step we take into the cosmos is meaningful precisely because the challenge is real.